Okay, so far we've been looking at sequences, which is basically terms or definitions for a bunch of numbers which have a specified order. Now, in studying series, we're going to add these numbers and discuss the nature of the sum. So, if an is an infinite sequence, a1 plus a2 plus an plus dot 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 to infinity is called an infinite series or just a series. We also write this using a summation notation an, where the index goes from 1 to infinity, or simply as an when the indices are obvious. So the goal is we're going to talk about adding up infinitely many things and recall the intro discussion that we have to be careful about it. The tool is we're going to begin with finite addition and then apply limits, which is the same tool as used in developing integrals. Given the series a1 plus a2 to infinity, we define another series, or we define a sequence Sn. We say that Sn is a partial sum of n terms. And then if the sequence is convergent and the limit of the sequence is S, then the series is convergent and the limit of the series is S. If not, the series diverges. So again, we're doing a classic trick of converting a new object into an older object using the properties of the older object to define properties of the newer object. For example, if we know that the partial sum is S given by 2n over 3n plus 1, then the sum of the series sums to the limit of the partial sum, which is the limit which is 2/3. Evaluate the infinite geometric series. Now, to do this, first of all, we use the formula for this is finite or sum of a finite geometric series. So, for this, what we need is the limit of the partial sums, which is going to be limit as n goes to infinity of a 1 minus r to the n over 1 minus r. Now this has to be the case that r is less than 1 and between 0 and 1, because in this case r to the n becomes 0. So this limit becomes a over 1 minus r, which gives us a formula for the infinite geometric series. But it's only valid when r is between 0 and 1. Because if not, it just diverges. It goes to infinity. So our basic property over here is that geometric series converges when for r between 0 and 1, and it converges to a over 1 minus r. We're going to be using this relation a lot in this chapter.